All right, guys, so here is the problem that was assigned on AP Classroom. It was using a lot of related rates. It's an application problem talking about circles on the screensavers. So part A, at the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of 3/2 centimeters per second. Find the rate at which the area of the circle is changing at that instant. Remember, I used to snap. We're talking about instantaneous rate of change. Indicate the units of measure. Notice how specific they were at asking for you to indicate the units of measure. That's a pretty good sign that that was a point on the scoring rubric. So when I introduced this problem on Monday, I said you needed to start with some sort of an area formula. So the area of a circle is pi r squared, right? So here we've got this circle, the radius was 9 centimeters, and it's only increasing at a rate of 3/2 centimeters per second. If we want to find the rate at which the area of the circle is changing, we have to take our amount equation for area and turn it into a rate equation. So we have to take the derivative with respect to time of the entire equation using our implicit differentiation, and we studied all of this in chapter 4. So the derivative of area with respect to time, pi is a constant multiple, so I'll leave him out in front. The derivative of r squared would be 2r using the power rule, but we have to apply the chain rule with respect to the radius here, so times the rate at which the radius is changing with respect to time. I'm going to be really specific here and make a table, even though most of you didn't do that, but this is how we would have done this problem when we studied these problems together. So figuring out which of these is the variable and which do I already have information for. Okay, so dA dt is the rate at which the area of the circle is changing, so I don't know that. At the instant we took a picture here to see what was happening with the circle, the radius of the circle was 9 centimeters. And the rate at which the radius was changing with respect to time is 3/2 centimeters per second. I'm going to go ahead and make sure my units are attached here. So now we're going to plug into our equation. Radius is 9. Rate at which the radius is changing is 3/2. 2 divided by 2 cancels to 1. Here we have 9 times 3. So the rate at which the area was increasing is 27 pi centimeters squared per second. This was the only thing that a lot of people got a point off on. If you didn't have this, you lost your third point. If we're talking about area, we measure area in square centimeters, so it should be square centimeters for every second. A lot of you just left it as centimeters or left it as centimeters per second. So go back and study what we talked about with units and think about all the comparisons I made you work on all year about comparing an amount to a rate. So here we have a rate is centimeters squared per second. Here we have the radius is centimeters. Here's another rate, centimeters per second. All right, that's part A.